Hello friends, today we are going to see about the stacks in which the subject algorithm and data structure. The first and foremost thing arises, what is stack? A stack is an abstract data type which is commonly used in most programming languages. It is named stack as it behaves like a real world stack. This is the stack of the books, for example, which is on the screen. It is nothing but the stacks of the books. For example, a deck of cards or pile of plates, etc. can also belongs to the stack. A stack is a data structure of ordered items such that the items can be inserted and removed only at one end. What it indicates? It means the stack is always open at one end, whereas it is closed at another end. We can perform the insertion and deletion operation on the stack. A real world stack allows operations at one end only. For example, we can we can place or remove a card or plate or book from the top of the stack only. Likewise, abstract data type allows all the data operations at one end only. At any given time, we can only access the top element of the stack. We cannot able to operate or we cannot able to access the bottom element or the random element from the stack. This features makes it makes the stack as LIFO data structure. LIFO. What is that LIFO stands for? LIFO stands for last in, first out. The element which is placed or inserted or added at last should be accessed first. In stack terminology, the insertion operation is called as push operation and removal operation is called as pop operation. As I already mentioned, what can we do with the stack? That we can perform these two or three operations. Major are two operations, that is push and pop. Push is place an element or insert an element on the stack or into the stack, and pop means look at that element on the top of the stack and remove that element. That means whatever the element which is located at the top of the stack, we can remove that element. Pick is another operation that we can perform with the stack. That means look at the element of the on the top of the stack but do not remove it. Means just only deal with that peak element. A stack is a LIFO data structure, that is last in first out data structure. A stack is sometimes also called as push down store. What are the question arises, what are the various applications of stack? With the help of stack, we may execute the program, we may execute the parsing also, we may evaluate postfix expressions also. That means conversion of infix to postfix, conversion of infix to prefix, conversion of postfix to prefix, and postfix to infix as well. All these notations are called it as the stack, which we can perform by or with the help of these stacks. Yes, the question arises, what happens if we try to pop? What happens if we try to pop? Pop means to remove an element from the top of the stack. What happens if we are going to perform the deleting operation, that is pop operation, an element of the stack when the stack is empty? Look at the look. If the stack is already empty, how can we perform the pop operation? How can we remove any element from the stack? It is not possible. In that case, it shows error and the whole stack goes the underflow process, that is stack underflow. The pop method needs some way of telling us that it has happened. In Java, we use the java.util.empty stack exception. Empty stack exception. Next is the question arises, how to implement the stack? A stack can be implemented by means of array, structure, pointer, and linked list. But majorly it deals with array and linked list. Stack can either be of fixed size one, or it may have a sense of dynamic resizing as well. Here we are going to implement the stack using arrays, which makes a fixed size stack implementation. Uh, as array, as I already mentioned, the bottom of the stack is data 0. Always the location is data 0, which is located at the extreme bottom of the stack. The top of the stack is data num items minus 1. Whatever the number items are there, minus 1 is the top of the stack. Okay. If we are perform that push operation, that means inserting a new element into the stack, we will have to express it or implement it by num items. Pop of the stack at the data num items minus 1. Basic operations that we are going to perform with the help of stacks are push and pop. The stack operations may involve initializing the stack, using it, and then deinitializing it. Apart from these basic stuff, a stack is used for two primary operations that I already mentioned. One is push and another is pop. Push is for storing or inserting an element into the stack, and pop is for removing or accessing an element from the stack. When data is pushed into the stack, to use the stack efficiently, we also need to check the status of the stack as well. For the same, for the functionality which is used or which is added to stacks is peek. Peek is the gate to get the top data element of the stack without removing it. We can also use stack is full, that means check if the stack is full. Stack is empty, check if the stack is empty. At all times, we maintain the pointer at the last push head data on the stack. At this pointer, as this pointer always represents the top of the stack, hence it is named as top of the stack or top. The top pointer provides the top value of the stack, which actually removing it, and the push operation, there are certain steps. How to implement? There are certain steps. The process of putting a new data element onto the stack is known as push operation. Push operation involves the following steps that I am going to explain right now. Step number 1 is check if the stack is full. Step 2, if the stack is full, it produces an error and exit. It produces an error. Which error? Overflow. Because the capacity of the stack is say of 5 elements, we cannot insert the 6th element at a time, because the capacity of the stack is already fulfilled. If we are inserting, it shows certain error and the whole process may exit, or it show the message stack overflow. If the stack is, step number 3, if the stack is not full, it increments the top of the stack by point next empty space. Whatever that top may be, it may increment by 1. Adds the data element to the stack location where the top is pointing, and step number 5 is returns success. If the linked list is used to implement the stack, then the step number 3, that is if the stack is not full, increments the top to point the next empty space, we need to allocate the space dynamically. As we know that linked list carries first, a linked list is divided into two parts. First is the actual data value and another one is the location of the next value. Same is with the pop operation. If we are accessing the content while removing the element from the stack, it is known as pop operation. In an array, implementation of pop operation, the data element is not actually removed. Instead, top is decremented to a lower position. Top is decremented to the lower position in the stack to point the next value. But in linked list implementation, pop actually removes the data element and deallocates the memory space. There are certain steps in the stack. Check if the stack is empty. Step 2. If the stack is empty, produces an error and exit. Step 3. If the stack is not empty, access the data element at which the top is pointing. Step 4. Decreases the value of the top by 1. Always, if we are removing an element from the top of the stack, ultimately the position of the stack or the value of the top of the stack is decremented by 1. Step 5. Return the success. Implementing a stack using linked list is not that bad either. It stores the item in the stack in the linked list. The top of the stack is the head node. The bottom of the stack is the end of the list. By push by adding to the front of the list and pop by removing from the front of the list. Same thing, if I am going to give this example with the help of this push and pop operation. Look over here, in the very first stack I inserted, initially the stack is empty. If I am going to perform the insert operation or what we can say that push operation, we can insert the element A in the stack first, then the top of the stack may get incremented by 1, then A, then N, then G, E and L if I am going to insert all these 5 elements, that is angel. At the same time, if I want to remove the element, always it may operate on the top of on the topmost element. The topmost element in this diagram, in this figure, is L. So if I am going to perform the if I am going to perform the pop operation, the L will get removed first. Look, in the bottom, the pop is there. A and G, E will remain as it is. The top of the stack, that is L, will remove first, then E, then G, then N, and then A. At last, the stack is empty. So we perform push and pop operation over here. Thank you for patience listening. In the next class, we'll see about, in the next lecture, in next video, we'll see about the various polish notations of the